The second method, we use the dimensional analysis to derive equation for the laminar flow. We can look at this. The condition, there are five variable delta P, V, L, diameter, and dynamic viscosity. So we have 5 variable and 3 reference dimension. So number of pi term is 2. Subtract 5, subtract 3 is 2. And we can derive the dimensions variable for two groups. That is the first group, delta P divided by mu V. And the second group is L over D. Okay. If we use the C is constant, so the two dimensional variable is the equal by the constant C. Okay. And we can derive the equation of V. Okay, is a function of this term, and the next we use V time area. Okay, so we need this term and time the area. So we got the next Q is equal to VA. Okay, from the so finally we got this equation. This you can look at this equation is similar to equation 6, except at the bottom is a 4C. For equation 6 is the in this case C is the must be determined by theory or experiment. For the round pipe, C is 32, so it will be 32 times 4. It should be equal to equation 6, 128. Okay, equal to equation 6. And from the next form, equation 5, this equation, okay, and we rearrange to get delta P and divide the both side of the dynamic pressure with this rho v square over 2 to obtain the dimensions form. Okay, so we got this equation, delta P divided by 1 over 2 rho v square, and we assume that is 64 divided by Reynolds number is the F. Okay, so we can write equation of the delta P divided by gamma okay, that is the delta P divided by gamma is a head loss. SF is a function of the FL over D V square over 2G. And for F is a function of the other parameter. So in this case, F we call the friction factor or Darcy friction factor. Okay, the friction factor for laminar fully developed pipe flow is the friction factor is a function of inverse proportion to Reynolds number. Okay. In this case, is once foot number increase. Increase, the friction factor decrease. And next, by substitute delta P in terms of the wall shear stress in equation 3 to obtain F friction factor as the dimensions wall shear stress, so we can get this equation. And for the turbulent flow, the friction factor is a function of Reynolds number and relative roughness. Okay.